So remember when you were back on the last page and we were using the left endpoints, now we have to start at x sub 0 because we're using 1, 2, 3, 4 lefts. We'll be stopping at x sub 3. So when I find the area this time, I'm going from I equals 0 to 3. And remember, we're doing delta x times f of x sub I. But for the last problem, we already figured out what delta x is. It's over here on the right-hand side again. So delta x was a fourth, and f of x sub I was 1 over 16 I squared. And hey, I have a rule for I squared. All this stuff out in front now is really just a coefficient. So of course I can pull that to the front. And then if you're really paying attention, you're going to go, wait, hold up, Torres. The rule for the I squared, and the I cubed is that I'm supposed to start at 1. And on this problem, we're not starting at 1. We're starting at 0. So, girl, what you be talking about? And I would say to you this. Is there a difference between this and this? And I want you to pause the video and think about that for just a minute. Of course, if I were to write this one out, I'd have 0 squared plus 1 squared plus 2 squared plus 3 squared. And if I were to write this one out, I have 1 squared plus 2 squared plus 3 squared. So the reality is that starting at 0 is exactly the same thing as starting at 1. So I can in fact use my rule for the summation of I squared, which is n times n plus 1 times 2n plus 1 all over 6. And of course n is 3, so I have 4, 7 all over 6. If I multiply that all out and reduce, oops, that's a 2. I get 7/32. Now, what I notice is that using these left triangles, so they were triangle 1, triangle 2, triangle 3, triangle 4, is that I'm a little short. Like here's some space that didn't get counted, versus on the last one, I was a little bit over. So now we want to use midpoints and see if we can get a little bit closer. So remember, on this one, I'm trying to attach to the midpoint of the rectangle. So it might be somewhere in here, the midpoint, somewhere in here, the midpoint somewhere in here, and the midpoint somewhere in here. And so here's my 4 rectangles. 1, 2, 3, 4. And so now, in order to calculate the area, I still have 4 rectangles, but now, and my delta x is still a fourth, just like it was in the last problem, the last 2 problems, because the width of those rectangles is a fourth, since I divided up this total space into 4 sections. But now I've got to find the y values for each of my midpoints. So in order to do that, typically when I do a midpoint problem, I usually draw a little number line, especially when the graph is minuscule like the one that we have. And so keep in mind that the x values are, or where I've drawn those lines, those vertical blue lines, are on those numbers. So if I'm looking at the midpoints for each of those sections, well, this one would be an eighth, and this one would be 3/8, and this would be 5/8, and this would be 7/8. So I want to find f of each one of these. And since I have my function, it's x squared, I'm just going to plug that in. So it's going to look like this. Well, actually, I don't even need that notation anymore. I'm going to expand it out. Silly Torres. So I'll be doing 1/4. And let's see. So f of 1/8 would be 1/64 plus, there's the summation. And f of 3/8, let's see, 3/8 squared would be 9/64. And 5/8 squared would be 25/64. And 7/8 squared would be 49/64. And so if I add those all up, I get 50, 75, and 9 is 84/64. And then when I reduce, I get 21/64. And ideally, because I've got, remember, a little bit under, but at the same time, I have a little bit over. So here's the over because it falls outside of the curve or above the curve. And so what we hope is that those two cancel each other out, therefore minimizing the how much I'm off. And so, of course, my answers so this was for midpoints. And so for the right endpoints, I had 15 30-seconds. For the left endpoints, I had 7 30-seconds. Remember, we said this one was going to be over, this one was going to be under, but for midpoints, I have 21/64, which would be illegally 10.5 30-seconds. And so you can see that this midpoint version is somewhere between the over and under answers. So this is the between. So I know that I'm getting closer.